Hello and welcome students to Make Pro classes, my official YouTube channel. Myself Piraj Mojumdar, Assistant Professor of Mechanical Engineering Department, GKCM, that is Greater Kolkata College of Engineering and Management under GIS Group. Welcome you to our new session of Advanced Welding Technology, where we will be uploading all the lecture series according to MacOut syllabus day by day. So keep in touch with us for getting daily updates. You can also contact me through 9433465217, that is my personal phone number, or even you can email me at pirasar@gmail.com. You can also connect me through social networking, that is Facebook page, which is known as Make Pro Classes. So let us start today's online session. We have completed the first topic, welding defects. We have discussed some of the types, causes, inspection, and in this class we will be having again different types of welding defects, and we will continue the previous lecture where we have already started discussing the welding defects, different types of welding defects and their causes. So let us begin today's class again on this welding defects. In the previous class, we have already discussed about the different welding defects. Along with that, we have also discussed about the structural welding defects as well. That is the deformation, the porosity as well. Now, let us begin with incomplete penetration. So actually incomplete penetration looks like this one. So this is the schematical diagram and this is the realistic diagram. So incomplete penetration happens when your filler metal and base metal aren't joined properly, and the result is a gap or a crack of some sort. Cause is low amperage, low preheat, tight root opening, fast travel speed, short arc length. Its prevention is correct the contributing factors, repair back gauge and back weld, spatter. As you can see over here, this is a spatter. The actual picture looks like this one, and here on the right hand side you will find the schematic diagram. So this is the actual picture what the weld spatter actually looks like. So spatter is when some small particles of metal that attach themselves to the surface of the material, that is the phenomenon known as spatter. Now what are the causes? Causes high arc power, damp electrodes. Now prevention is to reduce arc power, reduce arc length and use dry electrodes. Now repair is removed by mechanical process. Next is your overlap. It is caused by improper welding technique, steep electrode angle, fast travel speed. And what is the prevention? So prevention is, overlap is a contour problem. So in this figure you can find this is the overlapping. So overlapping. So this is a schematic diagram. So this is the overlapping, as you can see over here. Okay, so this is the overlapping. So what happens? Overlap is a contour problem. Proper welding technique will prevent this problem. Now the undercut is caused. So undercut you can see over here. Here is the undercut. So here you will find the undercut. Okay. So undercut is caused by high amperage, wrong electrode angle, long arc length and rust. Now what are the prevention? Prevention is sheet machine on scrap metal to correct parameters, clean metal before welding. Now repair. Weld with smaller electrode, sometimes must be low hydrogen with preheat. Now excessive concavity. It is caused by amperage and travel speed. Prevention is to observe proper parameters and techniques. Repair is to must blend smoothly into the base metal. Now look at the picture. This is the realistic picture. So in this picture you will find the excessive concavity, and right hand side you will find the picture with the schematic diagram. Okay, so that is the excessive concavity. Okay, that is the thing. So next we proceed to excessive convexity. Now look at the diagram. This looks exactly how the excessive convexity looks like. So it is caused by amperage and travel speed. So this is the throat. These are the throats, as you can see, and this is the leg length, sometimes denoted by S. For normal welding without any defect, the S is this height and this height. So these two heights will be same in the fillet joint. So this is the size length, weld size also tilt. So the prevention of excessive convexity is to observe proper parameters and techniques. Now repair must blend smoothly into the base metal. Now excessive weld reinforcement. This one looks like this one, excessive weld reinforcement. Now here you will find the face of the weld. This is the face reinforcement, and below is the root and reinforcement. So excessive weld reinforcement is caused by travel speed too low, amperage too low. Prevention is set travel speed and amperage on scrap plate. For repair, we have to remove excessive reinforcement and feather the weld toes to a smooth transition to the base plate. Now underfill. It is caused by improper welding techniques. Prevention is to apply proper welding techniques for the weld type and position. Use stripper bits before the copper pass. Now repair is to simply weld to fill, may require preparation by grinding. So this is the underfilling, as you can see over here. This is the picture of actual underfilling. So this is the picture of actual underfilling. Now causes and cures of common welding troubles. Brittle welds. The brittle weld is caused by wrong electrode, faulty preheating, metal hardened by air. Now what to do? Preheat at 135 to 260 degrees Celsius if welding on medium carbon steel or certain alloy steel. Make multiple layer welds. Anneal after welding. Use stainless or low hydrogen electrodes for increasing weld ductility. So here are some of the causes and cures of common welding troubles. Distortion of parts after welding. Now this is the transverse sinkage. This is the angular distortion in butt joints, and this is the longitudinal shrinkage. Now this is the weld. Now in fillet joint, this is the weld. This is the weld, as you can see. This is the neutral axis. This is the weld. Now again we have some
this is the underfill. As you can see, this is the underfill. This is symbol of a good weld. So underfill is this one. This is the crack, this is the inclusion, this is here also undercut, this is the porosity, and this is the overlap. Now weld defects. Defects which may be detected by visual inspection can be grouped under 5 headings. First is your cracks, then is your lack of solid metals, then is your lack of fusion, then is your lack of smoothly blended surfaces, then is your miscellaneous. Now types of welding defects: lack of fusion, undercutting, pinholes, cracking, misalignment, gas inclusion, porosity, craters, overlapping. Now defects affecting the quality of weld. It is the porous welds, poor penetration, warping, undercut and underfill, distortion, cracked welds, poor appearance, poor fusion, brittle welds, spatter, magnetic blow, weld stress. So these are the defects after the quality of weld. Now visual inspection. Prior to the welding, the base metal should be examined for conditions that may cause weld defects. Dimensions including edge preparation should be confirmed by measurements. Some of the more common welding gauges used in visual inspection are undercut gauge, butt weld gauge, and fillet weld gauge. Now welding inspection tool. These are the welding inspection tool. So you can see over here. Weld profile gauge. Scale in inches or millimeter, as you can see. Measuring fillet welds. This is the measuring fillet weld. This is the measuring bevel angle. This is measuring cap reinforcement or misalignment. This one. So this is a typical type of weld profile gauge, as you can see. Now defects is porous weld. Probable cause is short arc, insufficient padding time, impaired base metal, incorrect current, improper welding technique, speed too fast. Remedy: can hold longer arc, have to hold longer arc, have to use proper electrode, allow sufficient paddling time for gases to escape, remove impurities in base metal, use proper current, use waving motion to eliminate pinholes, weld slowly enough to get good root penetration. Now incomplete penetration. The probable causes are electrode is too large, current is too low, faulty preparation. Remedy for incomplete penetration. Select electrode according to welding group size. Use sufficient current. Calculate electrode penetration properly. Leave proper free space at bottom of weld. Warping. Probable causes are shrinkage of weld metal, faulty clamping of parts, faulty preparation, and overheating at joints. Remedy is to use intermittent welds, control cooling. Clamp parts properly. Pin joint edges before welding. Space parts properly. Increase travel speed. Use high speeds. Moderate penetration electrodes. Now, poor fission. Probable causes are incorrect speed, current improperly adjusted, faulty preparation. Remedy is to use correct speed, use proper current to allow deposition and penetration, use proper cleaning, edge preparation and positioning. Another is improper electrode size, improper welding technique. Remedy is to select proper electrode. Web must be sufficient to melt sides of joint, prevent weld metal from curling away from plates. Now, longitudinal cracks in heat affected zone. These are the longitudinal cracks. Now, what are the causes? The base material is prone to hardening because of a high carbon content or other alloying elements. So, weld cools down too rapidly. Hydrogen in the weld, that is because of the wet weld edges, wrong or damp electrodes or shielding gases. Remedies: if possible, choose a material with a better weldability. If not, apply and maintain preheat and interpass temperature and delayed cooling. Apply a higher preheat temperature. Remove moisture from welding zone. Use low hydrogen welding consumables from moisture protecting packagings or rebake welding consumables. Now, these are the solvents for dye penetration test. First is your degreaser or cleaner, metal cleaner, okay, that is a black. Next is your red dye penetrant, okay, for weld crack detection. Next is your white one, which is of detecting developer for weld crack detection. So, first is your cleaner or greaser, then is your red dye penetrant, next is your weld crack detection. So, these are the solutions you need to apply to perform dye penetration test to detect weld crack. Now, liquid penetrate inspection. Liquid penetrate is an NDT method that utilizes the principle of capillary action, in which liquid of suitable physical properties can penetrate deep into extremely fine cracks or pitting that are open to the surface without being affected by the gravitational force. So, this is a crack, as you can see. When red dye is poured in it, it is clearly visible. So, these are the different stages of dye penetration testing. So, here are the steps of dye penetration test. Penetrating, it is applying penetrant. Penetrant removal, whipping of excess surface penetrant. Applying developer with spray or brush. Observation, visual inspection. So, this is the crack, this is the penetrant, This is the cleaning, then developer, then developing, then is the indication or the interpretation. What type of continuities can be detected via penetration test? All defects that are open to the surface. Rolled products, that is cracks, seams, laminations, castings, weld shuts, hot tears, porosity, blowholes, shrinkage, forgings, cracks, slabs, external bursts, welds. In welds we have the cracks, porosity, undercut, overlap, lack of fusion, lack of penetration. So in dye penetration test we have some advantages as well as some disadvantages. So high sensitivity, rapid inspection, portable, low cost, visual inspection. These are the advantages. Now disadvantage is only surface defects it can protect. Okay, so pre-cleaning requires metal scanning requires. So these are the things you have to chemical handling and depositions. These are some of the disadvantages of the dye penetration test. So students, we have completed today the second part of the welding defects, as well as we have learned about the dye penetration test as well. So in the next class we will be having some more we will be completing this welding defects, and we will be having some more discussions on the different types of this testing of welded joints. Today we have discussed this dye penetration test. The next class we will be having some discussion on another testings of welding.